Okay, so welcome to your first video recording of the year. I have not done this in a while, so hopefully I don't mess up too bad. But I hope that you went over the homework and that you were comfortable with everything, and make sure you turn that in and that your name was on it. And right now I am in Austin, Texas, probably getting to my hotel, or nope, probably just landing in my plane. So that's what I'm doing as you're sitting here at the end of the day in school. So enjoy. All right, so today we're going to look at lesson 11.6. This is finding measures of angles in right triangles. So we've been talking about sine, cosine, and tangent and how we can use those to find missing side lengths. So today we're actually going to try to find missing angle measures. So if you know the sine, cosine, or tangent of angles in a right triangle, you can find the measure of the angle. You can do this using the inverse of each ratio or undoing the ratio. Okay, so you want to make sure you have a calculator for today. There's the bell, that's annoying. Okay, so we're going to be using the inverse sine ratio for an inverse cosine and inverse tan ratio for your lesson today. So you will need a calculator, so make sure you get a calculator. Okay, so let me scroll down here, and we're going to talk about what these inverses mean. Okay, so we use the sine, cosine, and tangent ratio when we find, to help us find missing side lengths when we have a reference angle. But if we have those side lengths, but we don't know the angle measures, we're doing the opposite, or undoing it. So we use the inverse. So like opposite, undo, inverse, they all mean the same thing. So this is where you use, this first one here is called inverse sine. This would be inverse cosine, and this is inverse tangent. Now, in order to activate this on your calculator, you're going to press the second button. And remember, if you were using a graphing calculator, make sure that your calculator is in degree when you go to the mode screen, not in radian. If you're using a regular red calculator, you should be fine. Okay. So these are the keys we're going to be using today on the calculator. So for example, if you know the sine of an angle is 0.7, you can find the angle measure using inverse sine in your calculator. So basically what you would do is you would press second sine to activate inverse sine, and then you would put in this number here, and it would tell you the approximate value of the degree of your reference angle. Okay, now this one, let me grab a calculator here because I did not do this one on my paper yet. You guys are probably already done with this. So we do second sine 0.707106781 equals approximately 44.9. So I'm going to say that that's about 45-degree angle. Okay. Now remember what I told you about how most of the time sine, cosine, and tangent ratios are going to be messy decimals or irrational numbers. Well, when that happens, like it does here, we want to round up to the nearest whole degree. That would make sense. Okay, so instead of saying 44.9 repeating for a degree, we would just say it's 45 degrees. Okay, so it's never going to be that exact. So let's go to an example. These you're just going to use your calculator to find what angles have the given trigonometric ratios and then round to the nearest degree. Okay, so that's important. So we're going to make sure that we are to the nearest whole number. So if we do sine of A equals 0.866025, we're going to do second and then sine. And when you put that in, you're going to get approximately 60 degrees. Okay, let's go ahead and try that. Remember, if I'm going too fast or you need Mr. Kovac to pause the video, just tell him and do that. All right, and then D, we're going to find cosine of D, so we're going to say second, and then cosine, put in 0.087156. And this will give us approximately 85 degrees. Okay, and then the last one is tangent of C. And we would do second tan. And that's going to give us approximately 19 degrees. Okay, so those should be pretty simple. Let's go to example 2. Example 2 says sometimes instead of being given one of the trigonometric ratios of an angle, you may be given the lengths of two sides of a right triangle. So we need to figure out what we're going to use. Okay, so you can use this information to write a trigonometric ratio and in turn use the ratio to find the measure of the angle. So in example 2 it says find the measure of angle M, so that's our reference angle right here, in the right triangle. Well, if I look at angle M and I see what I'm given 6, which is opposite, and I'm given 8, which is the hypotenuse. And opposite and hypotenuse is sine, okay? So opposite over hypotenuse. So that means that I'm going to do the inverse sine, so second sine, of the fraction 6/8, okay? Now when I do the inverse sine of 6/8, that turns out to be about 48.6 degrees, so we'll say about 49 degrees. So that means that the measure of this angle here, angle M, is 49 degrees. Okay? Then I know that P is 90, and I can find N by doing 90 minus 49, and that would give me 41. So N is 41 degrees. Okay? All right, next example. Sometimes you need to combine your knowledge of trig ratios with other geometric concepts to find the measure of an angle. So this is something that you should have went over last year. If you didn't, I'll do a little rundown of it right now. But this is an example of where we have two parallel lines, which would be, like say, this is line A and this is line B. So line A and B are parallel lines, and it's cut by the transversal line C. Okay? When you have two parallel lines cut by a transversal, you come up with some pretty unique types of angles. And these are angles that are equal to each other in some cases. So for example, if I look at angle 1, okay, angle 1 is equal to angle 2 because they are what we call vertical angles. Angle 3 and angle 4 are equal to each other as well because they're called vertical angles. Okay. Now, angle 1, 2, 3, and 4 are actually all equal to each other because 1 and 3 would be what we would call corresponding angles. 1 and 4 would be what we call alternate exterior angles, and 2 and 3 would be what we call alternate interior angles. Okay, now if you don't catch all that, that's fine. All I want you to know is that you recognize that 1, 2, 3, and 4 are equal to each other. Okay, in turn, that also means that 5, 6, 7, and 8 are equal to each other. Okay, so we could say that like angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. Okay, and then the other group of angles, we would say angle 5 is congruent to angle 6, which is congruent to angle 7, which is congruent to angle 8. All right, now, knowing that, let's go to our next example. Okay, so example 3, it says in the figure AD is parallel to BC. So here's AD, here's BC. Okay, this means two things. Okay, first thing is that AC is a transversal. And I know that because it's a line that's connecting and could possibly be going through, it's actually a segment, going through AD and BC. Okay, and because of that, that's going to give us those unique properties that we just went over. And also AB is a transversal as well because it's cutting through those two sets of parallel lines. Okay, so let's clean this up a bit and start from the beginning. So AD is parallel to BC. Find the measure of DAC. So I want to find the measure of this angle. Okay. Now, this looks like it could kind of be a problem because that's not an angle in the triangle. And when we work with trig ratios, we work with triangles. Well, because of what I just showed you before, I know that DAC is actually congruent to ACB, which is inside the triangle. Okay? Now I know that because these two angles are what we call opposite or alternate interior angles. Okay, so they are congruent to each other. And angle ACB is inside the triangle, which is what I want. Okay, so I'm actually going to use angle C as my reference angle. Okay, so if I look at angle C as my reference angle, I notice that I have what is opposite and what is adjacent. Okay, and the trig ratio that is opposite and adjacent would be tangent. So I'm going to use inverse tan. So you're going to do second tan, and opposite is 325 over adjacent is 400. And this is going to give you an angle that is approximately 39 degrees. Okay, so that means that angle C, okay, is approximately 39 degrees. Now, if angle C is approximately 39 degrees, because of the two parallel lines cut by the transversal and the alternate interior angles, that means that A or DAC, which I'm trying to find, is also 39 degrees. Okay? So that's how you can use other geometric concepts that you have learned in the past with trig ratios. Okay, so that's all the lesson is today. Hopefully we learned something new and we know what inverse, sine, cosine, and tangent are and why we would use them. I'm going to put this page up here, and you probably want to pause the video, do some of these examples. You can just complete them on the note page, or if you have a separate sheet of paper. You don't need to do all of them, just practice some of them. And Mr. Kovac has the answers, so if you want to know what the answers are when you are finished, ask him. If you guys want to work together, that's fine. Just want to do some of these practice problems, make sure you're on the right page with today's lesson. And then on Monday, you will do the graded worksheet that goes with this lesson. If you need to watch the video again on Monday, just ask them to play it again. And I will also post this on YouTube and put a link in your Google Classroom. Okay, so if you need to watch it over the weekend or whatever, you can do that as well. Okay, and I will see you guys on Tuesday.